Hello everyone, welcome to Chem 9 lab session. In this week's lab, we will learn how to synthesize aspirin. So as usual, the instructions for this lab are given in this first tab. Let's take a look at these instructions. So the objective of this lab is to prepare aspirin. The chemical name of aspirin is acetyl salicylic acid, and this is prepared by the reaction of salicylic acid with a compound called acetic anhydride. The chemical equation of this synthesis reaction is given here. From this equation, we can see that 1 mole of salicylic acid reacts with 1 mole of acetic anhydride, and it results in formation of acetyl salicylic acid. So this compound here, this compound is the aspirin. So this reaction is carried out in presence of an acid catalyst. In this reaction, we can either use a small quantity of sulfuric acid or phosphoric acid as a catalyst. The experimental video about this synthesis reaction has been provided in another video. In this video, we will only discuss about the data collection and how to use the data to complete the lab report. Once the reaction is over and we collect the product, the success of this reaction is determined by testing it with iron 3 chloride solution. So iron 3 chloride solution is yellow in color, and this solution reacts with the phenol group, and once iron 3 chloride combines with phenol group, the color of solution changes to purple. So in other words, if we add iron 3 chloride to any sample which contains a phenol group, the color of solution will change from yellow to purple. Now if we look at our equation, so we can see that in case of our starting material, we do have phenol group, but there is no phenol group in aspirin. So aspirin contains no phenol group. So if our reaction is 100% complete, 100% complete means that all of salicylic acid has been reacted and we have only aspirin as a product. And in that product, if we add few drops of iron 3 chloride solution, the color should not change because we do not have any phenol group. But imagine if our reaction is not complete, maybe only 50% is complete. In that case, half of salicylic acid has reacted and half has not. So the one or the percentage which has not reacted yet, so that salicylic acid will react with iron 3 chloride and it will change the color. So that's how iron 3 chloride solution helps us to identify if the reaction is 100% complete or not. So ideally, if our reaction is 100% complete, the color does not change. So therefore, we would like our sample to not show any color change or to not show purple color, because purple color means that the reaction was not complete and we still have some unreacted compound. The procedure to synthesize is provided here. I have posted another video in which this synthesis procedure has been explained. So please watch that video before completing the calculations. So in this video, I'm going to discuss the calculation part of this lab. So let's go over and take a look at what kind of calculations are there. So before we head on to the calculation, so let me briefly explain you what we are going to do. So in this reaction, we start with certain quantities of salicylic acid. For example, our instruction says that we are going to start with 0.150 grams of salicylic acid and this 0.350 ml of acidic anhydride. So the calculations are basically done to measure the percentage yield of the final product. In other words, starting from this much quantities of reactants, first we will theoretically calculate that how much product should be extracted at the end or should be synthesized, and then experimentally we'll see how much we obtain, and from those two numbers we will try to measure what is the percentage yield of our reaction. One thing I would like to mention here is that in the synthesis video they have used different quantities of starting material. Please do not use those quantities of starting material, and don't even use these quantities. We will use the numbers which are provided in the data sheet. So we will go over the data sheet and take a look at what are the numbers provided to us, and we will use the numbers given to us in the data sheet to calculate percentage yield and theoretical yield. The data needed to complete this lab report is given in this sample data tab, and as usual the lab report is in this tab. So let's see how to use sample data to complete this lab report. So let's open the lab report. Okay, so let's have the data and lab report side by side so that we can see which data goes where. Okay, so here is our data on the left hand side and our lab report on the right hand side. Okay, so the first section where we're gonna need data is the amount of salicylic acid used in grams. So the value of salicylic acid used is given here. So any number between 0.125 and 0.175 will go here. So I'm gonna use the first value, so please use some other value. So I'm just gonna use 0.125. But you should use some other value anywhere between 0.125 to 0.175. Next is moles of salicylic acid. So when we know the grams of any compound, we can calculate the moles easily. I'm gonna write the easy equation. So moles of any substance is equals to grams of that substance divided by molar mass. So if you use this equation, you can calculate moles of any substance as long as you know the grams, as long as you know the molar mass. So in our case, we already know the grams. So the grams is, I'm using 0.125, you may use some other number. And fortunately, the molar mass of salicylic acid is also given. So this is the molar mass of salicylic acid, 138.121. So dividing the mass with this molar mass will give us moles. So therefore our calculation will be 0.125 divided by 138.121. So whatever the answer comes, that should be the moles. So as you're gonna use some other value, so your value will be slightly different than my value. So I'm not gonna calculate the answer here yet. I'm just gonna assume that the answer comes out to be A. The next is the amount of acidic anhydride used in milliliters. Ignore this warning because I have not entered any number, so that's why it's telling me that A is not the correct value, which we know it's not correct. Anyway, so the amount of acidic anhydride used is given here. So this is the amount of acidic anhydride used in milliliters. So any number from 0.232 to 0.37. So I will use 0.31 just to be different, but you should use any number given in this range, otherwise the answers will not be accepted. The next is the mass of acetic anhydride. So mass can be calculated from the volume if we know the density, and density is given to us. Density of acetic anhydride is given here. So therefore the formula is, we know that density is equals to mass over volume. So we know the volume, we know the density, therefore mass is equals to density multiplied by volume. So this is the formula to calculate the mass of acetic anhydride. So volume, I'm using 0.31 multiplied by density. So the value of density is 1.08. So whatever the answer is, that should go here. So I'm going to assume that this answer is B. The software again gonna give me warning that B is incorrect. There we go. Next is moles of acetic anhydride. So the mass is calculated here. I got some number, you will get some number, and the formula to calculate moles is given here. So therefore it means that we need to know the molar mass of acetic anhydride, and that value is also given here. So this is the molar mass of acetic anhydride, 102.9. So if we use 102.9 as molar mass, and grams will be the value which you get here on in this box, and dividing those two values, so you should get the moles. So I'll say B, whatever that B is, divided by 102.09. so this should give you the moles of acetic anhydride. So whatever the answer comes, you should write that answer. I'm gonna assume that the answer is C. Next is mass of product obtained, and again there is a range given to us. So any value between this range is the mass of product obtained, and remember product is aspirin, and we can use any value starting from 0.110 to 0.125. so I'm going to assume 0.110. You should use some other value. So that's the mass of product obtained. Next is moles of product obtained, and formula is still the same. Excuse me. So this is the formula. Moles of anything can be calculated. So grams are given to us. If we know the molar mass of product, we should be able to calculate the moles. Fortunately, the molar mass of product, which is aspirin, is also given. That's 180.158. So using the formula, we can calculate moles of our product to be 0.110 divided by 180.158. so the answer to this should go here. So I'm going to assume the answer is D. So that should be the value here. So next is product theoretical yield. Now theoretical yield is calculated by stoichiometric calculations, and in the procedure we saw the balance equation, and in the balance equation you can see that one mole of salicylic acid gives 1 mole aspirin. So equation is completely balanced, so it's 1:1 equation. So using this we can calculate the theoretical yield. Okay, so we can calculate the theoretical yield using this calculation. So theoretical yield is calculated from the balance equation, and as we discussed earlier, in balance equation given in the procedure, we can see that 1 mole of salicylic acid gives us 1 mole of aspirin. So we will use it as a conversion factor. And other thing to note here is that we need to calculate theoretical yield in grams. So how many moles we start with? So the moles of salicylic acid which was taken in the beginning of reaction, in my case is A, in your case will be some number. So that's the number of moles what we started with. So moles of salicylic acid. So from this moles we gonna theoretically calculate the moles of aspirin, and then we're gonna theoretically convert the moles of aspirin to grams of aspirin. So that should be our theoretical yield at the end. So whatever this grams is, this is the theoretical yield. And we're gonna need a conversion factor here, and we're gonna need a conversion factor here. So moles of salicylic acid, what we started is this number here. So I will say A moles multiplied by. So the conversion factor between salicylic acid and aspirin gonna come from this relationship. So it will be 1 mole salicylic acid, and remember this is salicylic acid, right? And 1 mole aspirin. So moles of salicylic acid cancel with moles of salicylic acid. So now we have A multiplied by 1, that should be A moles of aspirin. So we have moles of aspirin up to here. Next is we need to convert moles to grams. Again, the formula or the conversion factor gonna come from here. So that is the relationship between moles and grams. So 1 mole of salicylic acid, or excuse me, aspirin. So 1 mole aspirin multiply on top will be 180.158 grams. So moles of aspirin cancel with moles of aspirin, and whatever number you get here, that should be our theoretical yield. To simplify, it should be equals to the A multiplied by 180.158 grams, where A is the moles of salicylic acid we used in the beginning. So that should give us the theoretical yield. So this is the theoretical yield in the simplest words. And that's the explanation how we got this theoretical yield. Okay, so whatever the theoretical yield you get from this value, so let's call that theoretical yield to be X grams. Well, X looks like a cross, so let's use some other value. Let's say it's the M grams. So that value goes here, so M grams, and the product percentage yield is, so the percentage yield is, let me calculate right here formula. So percentage yield is the grams of product obtained divided by theoretical yield multiplied by 100. This is the percentage yield. Now the grams of product obtained is here 0.1110, so 0.110 divided by the theoretical yield. In my case, I assumed it to be M. So, but you should use your number multiplied by 100. So that should give you the percentage yield. So these are all the calculations you need for this lab. Next is the observation from the iron chloride test. There is a mistake in the data. I'll discuss about that. So salicylic acid, as we learned in the beginning of this discussion, that iron 3 chloride reacts with the phenol group and the color changes to purple. Okay, so in case of salicylic acid, when it reacts with iron 3 chloride, the color changes to deep purple. So that is the observation here. So you should write deep purple. The observation when we added acetyl salicylic acid, and the observation is light purple. So you should write light purple here. Now the mistake here is that the product, as we discussed, if the reaction is 100% complete, there should be no phenol group. No phenol group means color should not change. It should stay light yellow. But instead here it says deep purple. So I would like you to cross this out. Don't use deep purple and use light yellow. Light yellow means no reaction. It should not, product should not give any reaction because there is no phenol group. So you should write here light yellow, which should be same as the control color. And post lab question, please answer whatever you feel like. The first question is your percentage yield within reason of what you would expect? Explain your answer. Normally in organic reactions, the percentage yield is not going to be 100%. That's obvious because we always lose some product, but it shouldn't be too low. So any value between 80 to 100% is considered good. If it's less than that, you should have a good reason why it is less. So based on your calculation, you explain if your percentage yield is good or not good, and whatever answer you can think of that why your yield is low or high. Does your melting point indicates your product is pure? Okay, so maybe we missed melting point. Oh, here. So the product melting point, so write the value here and the given value is here. So what I want you to do is, so pick a number from here and write it there. So that should be the answer. Now here when you have to answer if your melting point indicates good product or pure product or not, the answer is if your observed melting point is same as the reported melting point in book or online, then it's pure. So what I want you to do is go online and find out the melting point of pure aspirin and then see how your value compares to it. If pure aspirin melting point is 130 and yours is also 130, then your product is pure. Slight difference in melting point is still okay, but imagine if the pure melting point is 152 and yours is 132, that means it's not pure. That means there are some impurities. So explain based on that reasoning. And again, describe the results of iron 3 chloride test in your own language. So we have already discussed it and used that. There are no pages to upload. Please ignore this and please ignore this also. This is for TAs, so don't worry about it. So ignore the last two uploading files. So this is the lab number, I believe 14. Yes. And if you have any other question, please let me know. Contact me by email or office hours, and I'll be more than happy to answer all your questions. Thank you for watching the video. Have a wonderful rest of the day.